Okay. So we were talking about the two groups we found. Okay. So we found out that the two groups of interest here. One second. Sorry. I don't know why the screen is doing this. Okay. So we were saying that the two groups we found are the groups of Reynolds, okay, and the group of F. Okay. Now, what will happen is that how to conduct experiments, how to know how charts will be drawn. Since here you have only two groups, it's very simple how to draw the graph. You just have to vary one of your dimensionless numbers and measure the other. So for example, already rho UL are your parameters. So to change Reynolds, it's enough for you to change the velocity of the fluid, which is the easiest parameter to change in this case. Because to change the rho or mu, you should change the type of fluid, and L, you should change the length, the characteristic length. So the easiest way here will be to change the velocity, the upstream velocity. In this way, you can modify Reynolds. And your experimental setup will allow you to measure the force F resulting on your system and to calculate the corresponding group of F. So you can draw a graph of F over rho U square L square. This term is a coefficient, okay? It depends if the force F is in which direction to determine if it's a drag or lift coefficient, okay? And then you will get a graph, for example, for this factor function of Reynolds number, for example. Okay. Now, in case, for example, we had an additional parameter, which is the roughness. If I add for you in this problem the roughness of your object, then you will say the number of the number n will be equal to variables will be equal now to 6, and the dimension of epsilon is L. So the group formed by epsilon, you will still have here j equal to 3 because you have MLT, and you can find 3 independent variables اللي هن زيتون rho u and L, or you can take rho u and epsilon if you want. But in general, epsilon, okay, we consider that L is easier to change than to change epsilon. So we consider that these are the independent variables, and then the corresponding group will be epsilon over L. Okay, so if you want, in this case, to present a chart, you will do the following. First, you will take the axis as F over rho U square L square, and this axis is Reynolds. And now you will draw curves for each value of epsilon over L. So you can fix epsilon over L, draw one curve, then change epsilon over L by changing L, for example. You can get a new graph for another source. This is epsilon 1 over L. Epsilon L equal to 0.1, for example. You can draw for another value, epsilon over L equal to 0.2, another graph, etc. You will end up with a series of graphs presented on your chart. Okay, so this is how you can, from this analysis, determine how you will conduct your experiments and how the charts will, what will be the shape of your charts, if you want, the form of your charts. Any question on this? Okay. So now let us do another example to illustrate sometimes what will be the problems that can be faced with J. So if you remember, I told you J is the maximum number of independent variables. So sometimes we might not be able to find J. So we can write just J, let's say equal smaller or equal than 3 if you have only MLT, but it might be smaller than 3. We'll see this example to understand why. Okay, so we are doing now another example. Assume that the tip deflection delta of a beam is a function of the tip load P, the beam length L, the area moment of inertia I, and the material modulus of elasticity E. That is delta function of P, L, I, and E. rewrite this function in dimensionless form and comment on its complexity on finding the value of g. Okay. So as usual, what is step one? Step one is to put our variables in a table and set the dimension of each variable. So delta is a deflection. It has a dimension of length, so it's F. P, okay, is the load. It's a force, so the unit is MLT minus 2, F equal MA. We have the length of the beam is L, of dimension L. The moment of inertia of the beam, if you remember from static, when we talk about moment of inertia for an area, it's dimension L to the power 4. So for example, if you have a rectangular section, for example, this is A, this is B, I is, with respect to this axis, is A, B cube over 12. So the dimension is, A is length, B is length, so it's length to the power 4. So for the moment of inertia, it's L4. And finally, for the modulus of elasticity, you might not know it, okay? This is why you can go back to definitions. I don't know if you have taken mechanics of materials. If you have taken mechanics of materials, okay, you have a relation between the elasticity coefficient. You remember when you draw stress function of sigma function of delta L over L, which is epsilon, you remember? And you come up with, in the elastic region, you have the modulus of elasticity is the slope. So you can write that sigma is equal to E times epsilon. Epsilon is delta L over L, so no dimension. This means that E, the modulus of elasticity, has the same dimension of the stress, which is in Newton per meter square. And Newton per meter square is force, which is MLT minus 1, MLT minus 2 over L2, L square. So you end up with ML minus 1, T minus 2. Okay. Of course, in general, when we give you something new, we should define it for you. And we tell you that the modulus of elasticity is defined by this. So, and you know that sigma is a stress, and they tell you epsilon is delta L over L. So you can find the corresponding dimension of E. Okay, so this is the first step done. Whenever I'm done with this step, I can find the number of variables. So first n equals 5. And now J is maximum equal to the number of dimensions involved. You have L, M, and T. So J will be smaller or equal to 3. I start first I start if I can find J equals 3. So I try to find 3 variables that cannot form a group. And let us see if this is possible here or not. Okay, for example, let us say I want to select first a variable that only contains M. So P, for example. Okay, I need other 2 variables. I take L then. Now I need a third variable only containing that is containing, for example, T with L. I cannot find. Look, if I take I, for example, L and I form a group. So I cannot say that P, L, and I are independent because L and I have the dimension of L is L. The dimension of L is 4. So if I do I over L4, I get a group, a dimensionless group. Okay, so these 3 variables are not independent. So here, how you can know directly that I cannot form, I cannot select 3 variables to form independent group, because already you have 3 variables, delta, L, and I. If you combine 2 of them directly, you will have a group. Plus, the second thing is that the 2 remaining variables, P and E also. Okay, so if you, let us say, I don't want to select 2 variables, Li or delta, between Li and delta. So I will have to select then P with E and a third one, let's say F. Why these 3 will form a group? Because look, for For P, it's containing M and T in the same way. So it's MT minus 2, and this is MT minus 2. So MT minus 2 will cancel out. And to cancel L minus 1, okay, then all I have to do is proper combination with L. So I multiply by L. This means if I do this, if I do P over E, okay, what do I get? If I do P over E, I get the unit L. So now if I divide by L, P over EL, I will get dimension 1. So they form a group. This means that I cannot select any 3 variables that cannot form a group. Okay, this is why I should move to J equals to 2. How can I expect this? Okay, I can expect this as I told you, because I cannot select a group containing 2 of Li and delta. And it's impossible to take L with I with something with a third thing, because already they cancel out with each other. And also I cannot take P and E together with a third variable, because P and E will cancel MT minus 2. Because if you want here, MT minus 2 is repeated in the same form. So I cannot consider M variable لحال و T variable لحال, because they are configuring together in MT minus 2. يعني كأنهم إذا بدكم new unit. يعني كأنه 2 units اللي عندي إياهم هون هن MT minus 2 و L. Okay, because you know that combination of 2 units can give you another unit. مثل ما بالام ال تي فينا ننقل للاف ال تي، نفس الشيء هون فينا نعتبر هيدي dimension جديده. And I just have 2 dimensions that are repeating in this case. This is why J is not equal to 3 here. It will be equal to 2. So I can only select 2 independent variables. How to select them? I have several choices. Okay. I can take, of course, length of the beam can be easily changed. So I can select it. And I can select now the second variable, or the force P, or the modulus of elasticity. بس عادة the force P is an output. يعني I want to measure, let's say, the force I measure. Okay, so I can take as 2 independent variables, for example, L and the modulus of elasticity. This is not the only possible choice, but it is one of the reasonable choices, because these 2 parameters can be easily varied experimentally, and others are outputs. Yani P for me in general is an output. I measure the force, I measure the deflection. Okay, so let us say we considered that the 2 variables are L and E. Okay, now we'll proceed to the second step. What is the second step? To form the groups. Here, how many groups do I have? I have N minus G, N equal to 5, and G equal to 2, so 5 minus 2. Then I can form 3 groups. I am able to form 3 groups. Okay. Now, how to form these 3 groups? First, I take the remaining variables with the 2 independent variables. The first variable is I. Okay. So I want to form a group between I, L, and E. Automatically here you can directly find this group. مثل ما قلنا سوا انه I unit تبعها L4 و L unit تبعها L dimension L. So automatically the group will be I over L4. Okay. هلا اذا بدنا نعمل اذا طلبوا منا to go through the pi group method مفروض نعمل steps لو نحن بنعرف شو حيطلع الجروب. Okay. So all we have to do is to set coefficients A, B for L and E, and for I1. So you replace dimension of L is L, dimension of E is M, L minus 1, T minus 2B, and I is dimension is N to the power 4. And since we select exponent 1, يعني هي L4, equals to M0, L0, T0. The first equation then will be the equation of coefficient of L. فنحطها سوا. عندنا L to the power A, عندنا هون minus B, و plus 4 equal to 0. This is equation number 1. Okay. Second equation for M. For M, we just have M configuring one time here. It's M to the power B. So M to the power B So B is equal to 0. Okay, so B from one side is equal to 0. So what is the coefficient B? B is 0. Then replacing back here B by its value, you will get A equal to 4. Okay, and now you can verify the third relation. For coefficient L, you have A minus 4 equals 0. So again, A equals to 4. Okay, so in this case, you will not obtain 3 unknowns, you just have 2 unknowns. So the first 2 relations will give you A and B, and the third one will be just a verification. Okay, now if I move to the second group, now the second variable of interest is force P. So I put also L power A, E power B, P power 1 equal to M0 L0 T0. And again, I find 2 equations. I get the 2 coefficients A and B. So I end up with P equal to E over L squared. Also, this is expected because we said that E has the unit of stress and force is stress times area. So always you can verify your groups, that your groups make sense. Okay. And finally, the third group is formed with delta. This is the easiest group. So delta has the same dimension of L. So of course, the group will be delta over L. So you can say now that since your main interest is delta, then you can write the group delta over L is a function of 2 groups, which are P over EL squared and I over L. So here, if you want to provide charts, what you can do is the following. You can say I will select as y-axis delta over L, because this is my final output desired. I can put on x-axis the group P over EL squared. And then I will draw several curves, okay, for different values of I over L4. So I will end up with different curves. And for each curve, I have a certain value of I over L4. So this will be the form of my experimental chart provided. And then anyone who has an experiment on a beam, whatever is the size of this beam, the elasticity coefficient, he can use this general chart by using the dimensionless groups. Okay. Any question on this?
Doctor?
Yes, Hassan.
بس in the first step بس بدنا ننقل independent variables أنا بحق لي يعني أضربهم ببعض أو أقسمهم على بعض أو أحط لهم powers حتى أجرب فيهم يعني؟
أكيد. أنت إذا بتقدر تلاقي جروب بين 3 يعني ما فيك تلاقيهم 3 independent variables، فيك تقسم تضرب تعمل بدك اياه. هلا كيف فيك دغري تعرف انه مثلا دلتا وال واي ما فيهم غير ال، يعني اوتوماتيكلي بس تجمع 2 منهم حيكون في جروب اوريدي دغري. اوكي يعني مستحيل اجمع 2 من هول دلتا ال مع اي، ما فيني نقي 2 منهم دغري بيعملوا جروب. فاذا بدي اخذ بس وحده منهم، let's say ال. هلا ال بدي اعمل لها كومبينيشن، بدي اجرب فينا اعمل لها كومبينيشن مع بي واي اثنيناتهم، كمان ما بتزبط لانه مثل ما شفنا انه ام تي ماينس 2 بتروح، فبصير فيني اعمل جروب. يعني ما عندي تشويس غير اخذ مثلا ال اي او دلتا مع بي او مع اي.
يس لانه انا كنت مفكر اخذ اي اوفر ال تطلع 1 على ال باور 3 فكرتها.
لا ما هن بيعملوا جروب. انتبه كيف الجروب، مش ضروري اي اوفر، فيك تعملوا اكسبوننت يعني اي اوفر ال 4 بيعملوا جروب صح؟
هيدي الفورم.
بمجرد اذا بتلاقي اكسبوننت يعمل جروب خلص يعني بيعملوا جروب، بمجرد ما عملوا جروب يعني ما اندبندنت.
يس دكتور.
اوكي ناو من بعد ما شرحنا هلا حارجع انا وياكم للستبس نتاكد انهم واضحين. اوكي now you will understand better if we so the first method of determining groups is the Buckingham Pi theorem. Now what are the steps? Step 1, list all the variables that are involved in the problem. This step is the most difficult one, خصوصا اذا مش هن عطوني شو هن الفاريبلز. يعني عادة أنا بدي أقرر حسب الامبورتنس للفاريبلز إذا هن should be included or not. أنتوا بتعرفوا إنه في كتير parameters معقول فوتهم، بس هي قصة الشطارة هي إنه فوت البارامترز الاساسيين اللي عن جد عندهم effect. هلا كيف بنعرف؟ اكيد فينا نعمل experiments، فينا مع الخبره نعرف، مثل ما شفنا انه بس يكون في flow صار automatically في row وميو وفي مثلا. اوكي. So this step is the most difficult one, and it is of course very important that all pertinent variables should be included. Otherwise, the dimensional analysis will not be correct because it will be missing important values. We are using the term variable to include any quantity, including dimensional and non-dimensional constants, which play a role in the phenomenon under investigation. All such quantities should be included in the list of variables to be considered for the dimensional analysis. So this is the first step. Second step, express each of the variables in terms of basic dimensions. هيدا التابل كنا عم نعمله سوا. For the typical fluid mechanics problems, the basic dimensions will be either ML and T or FL and T. Dimensionally, these two sets are related through Newton law. نحن تعلمنا كيف ننقل من system للثاني because you can just replace F by MLT minus T. Now, the third step is to determine the required number of pi terms. وهيدي أكثر وحدة يمكن هلا صرتوا تفهموها بس قبل it's hard to understand. If a physical process involves n-dimensional variables, it can be reduced to a relation between only k-dimensionless variables or groups. The reduction j equals n minus k equals the maximum number of variables which do not form a pi group among themselves and is always less than or equal to the number of dimensions describing the variables. Okay? حدا ما فهم شيء بهالسنتنس هلا؟ Okay. Now, once I find G, so to find G, I initially guess G equal to the number of different dimensions present and look for G variables which do not form a pi product. If no luck, reduce G by 1 and look again. هلا هن هون بس قالوا لكم تقلعوا انه جربوا، بس انا كمان اعطيتكم technique that can help you to know. مثل انه شفنا انه mt minus 2 عم تتكرر بنفس الطريقه، so كانه هي 1 unit، so استنتجنا انه J cannot be 3. Okay, and with practice you will find J rapidly. The fourth step is to select J scaling parameters which do not form a pi product. Make sure they please you and have some generality if possible, because they will then appear in every one of your pi groups. هذا اللي حكينا عنه انه عادة بنلاقي parameters that are easy to change. Okay, pick density or velocity or length. Fifth step, add one additional variable to your J repeating variables and form a power product. Algebraically, find the exponents which make the product dimensionless. Try to arrange for your output or dependent variables, force, pressure drop, torque, power, to appear in the numerator, and your plots will look better. This sequentially adding one new variable each time, and you will find all groups desired. 6. Write the final dimensionless function and check your work to make sure that all pi groups are dimensions. Okay, any question on these steps? So this is the first method to determine groups. We have several methods. Another one is by inspection. Okay, it's also an easy method. Let us go over it. So the second method to determine pi groups is the inspection method. This method of repeating variables for forming pi terms has been presented in section 7.c. This method provides a step-by-step procedure that, if executed properly, will provide a correct and complete set of pi terms. هيدي اللي شفناها أنا وياك. Okay? Although this method is simple and straightforward, it is rather tedious, particularly for problems in which large numbers of variables are involved. Since the only restrictions placed on the pi terms are they should be correct in number, dimensionless, and independent, it is possible to simply form the pi terms by inspection without resorting to the more formal procedure. Let us see how. Okay, so to illustrate this approach, we will take another example now together. هنعمل method إذا بدكم اسمها inspection or elimination also we can call it. شو هي idea of this method؟ هلا أول steps are common. أكيد I should list the number of variables. First, I should determine if you want how many variables I have and how many groups I can form. هول نفس الشيء. Okay. So let us say you have the pressure per unit length. So you know that the pressure per unit length dimension احنا بنعرف انه pressure هي FL minus 2 وبما انه per unit length يعني we are dividing again by L بتصير FL minus 3. اوكي. عندنا كمان الديامتر دي is L الرو هي هلا اذا عم بيشتغل هلا هن بقوا يشتغلوا بالاف ال تي سيستم. اوكي. نحن بنعرف انه بالام ال تي رو is kilogram per meter cube يعني m over L minus 3. So all you have to do is to replace m. نحن بنعرف انه f is mlt minus 2 صح؟ So I can replace m by what? By f t square over L. So I can replace m by f times t2 over L. If I do this in this expression, I will get that density is FL minus 4 T2. Okay. And viscosity كمان بعرفها بالام ال تي فينا نحولها او كمان تعرفوها دغري الفيسكوسيتي اذا بتتذكروا هي باسكال سكند فدغري فيكم تجيبوها بالاف ال تي system because Pascal is FL minus 2 and time is T. And finally the velocity is LT minus 1. So here the number of variables is 5. Okay. And here automatically بتطلعوا عندي 3 independent variables معروفين يلي هن rho dv. So خلص automatically عندي j equals 3 because هون I have FLT يعني j is smaller or equal to 3 and already I have 3 variables that are independent يلي هن rho dv. So automatically I can say that j is equal to 3. So I am sure now that the number of groups is only 2. So I can form a group with delta p and a group with mu. هلا الجروب with mu صرتوا تعرفوا انه هو رينولد يعني فيكم هون اذا بدكم you can directly expect انه this group will be the group of Reynolds rho vd over mu بيبقى الجروب of delta p. اوكي. هلا delta p هي pressure per unit length هي FL minus 2. خلينا نعملها انا وياكم by the inspection method. شو فكره الانسبكشن method؟ Inspection method will try to eliminate if you want one dimension after the other. Yeah, what do we mean by this? First, what is dimensions involved in delta p? F and F. Okay. So first I say to cancel F, I will divide by a variable by one of the independent variables containing F. أنا شفنا أن independent variables هن rho, V و L. V ما فيها F و L ما فيها F. يعني the only variable containing F هي rho. So I start by dividing by rho to eliminate F. Since the unit of rho is F, dimension of rho is F, L minus 4 T square. So I divide just by rho and F will be eliminated then. And the result will have as unit L over T square. Okay. Now, next step, L over T square, I will eliminate time then eliminate L. Okay. Why I will do this؟ لأنه طلعوا V الوحيدة اللي فيها time هي V هي L over T. بينما ال L موجودة باثنين. So على طول بجرب first to eliminate الفاريبل الموجودة once. يعني بلشنا أول شيء بالF موجودة بس برو راحت الF. Now T is only present in V, so the next step is to eliminate T. So I divide by, here I cannot just divide by V, I need to divide by V square. Why? لأنه أنا بدي T square. Okay. و V فيها T to power 1, T minus 1. So I should divide by V square so that to eliminate T minus 2. So when you divide by V square, you will get T minus 2 هون times T2. They will cancel out and I will just have 1 over L. لأنه هون عندي L هون عندي 1 over L square. So I end up with 1 over L. So until now I canceled F, I canceled T. I still have to cancel L, which is very simple to do here. And this term is 1 over L. I just have to multiply it by L. يعني the final result of my group شو حيكون؟ عندي I first divided by rho, so delta P over rho بيرجع divided by V square بيرجع multiplied by L. So my group will be delta P per unit length times L over rho P square. Okay, so this is my group. So this can be this is an easy method لما يكونوا الفاريبلز إذا بدكم مش موجودين بعدة parameters. يعني إذا f موجودة بثلاثة مثلا it will be very challenging. بصير بدي كثير جرب تقدر أعمل inspection method. Inspection method is recommended لما يكونوا independent variables يعني في وحدة منهم فيها f لحال وحدة منهم فيها t لحال وإلا بصير بدي أقعد جرب. It's not easy then. Okay. ساعتها أحيانا أعمل الباي جروب ميثود الباكنغهام ثيوري. اوكي. وفي الميثود اخر شيء اللي على الخبره بنصير نعرف الجروبس بس هن بس يطلبوا منكم ميثود you should يعني do it. يعني مثلا لو انتم بتعرفوا انه رينولد انه ميو بتعطيني رينولد مع رو في دي بتكون بس اذا طلبوا منكم باكنغهام ثيورم you should do the derivation. اذا طلبوا منكم inspection كمان you should do the derivation. Okay. Let us try to do it for mu بما انه نحن بنعرفها بس let us try to practice on it with mu. So if I want to find the group of mu شو بدي اعمل؟ اول شيء شو الunit of mu؟ unit of mu fl minus 2t. So first to cancel f what should I do? I should divide by rho. اذا بعمل mu over rho شو بيطلع لي؟ The dimension of mu is f l minus 2 times t. The dimension of rho is f L minus 4 T square. So by doing mu over rho F will cancel out. شو بيضل عندي؟ بيضل عندي L square over T. Okay. Second step بما إنه V بس فيها T I will eliminate T. To eliminate T what should I do here? I should divide this result by V. يعني now if I divide mu over rho by V okay شو بيصير عندي؟ بيصير عندي إنه هون I should multiply by t and divide by l. So what will happen then? أشيل هيدي step. Okay. t و t بيروحوا. شو بيضل؟ بيضل l square over l equal to l. And finally, how to eliminate l? All I have to do is to divide here by l. يعني now I have l over l. Dimension is 1. So at the end, what I should do is to divide first by rho, then by v, then by l. And the group that I will obtain is mu over rho VL as expected, which is the Reynolds number. So now the two groups I obtained are delta P times D over rho V square and mu over rho VD. So I can say that my groups, I can just have to do an experiment. I have on one axis this group and on the second axis Reynolds number, and I have to just plot one curve in this case. Okay, any question on this? So this is about the groups and how to determine them by different methods. We'll continue this chapter hopefully next time. Okay, thank you. Bye bye.
دكتور
Yes حسن.
في شغلة بس بدي أسألك عنها بالبريفيوس.
Yes. Tell me. Let me just stop recording.